Now the next couple are with reaction mosaic ions with ammonia, which actually aren't too bad. The only one that's bad is copper. And you'll see why in a minute. Okay, so FeH2O6 2 plus 2 NH3s for FeH2O4 OH2 plus 2 NH4 plus. Then you've got Cu. I'm going to do copper last because it is the worst one. Just get you guys nice and introduced. So obviously I'm going to have 3. I'm going to add 3 ammonia because it's a 3 plus charge. So, you know, it is just memorizing equations, but it's also using some intuition to help you memorize them easier. And then with aluminium, it's the exact same thing. Plus 3 NH4 plus. Now with copper 2 plus 2 NH3s to form CuH2O4 OH2 plus 2 NH4 plus, yes. And then you've got another thing. And it is with 4 NH3s. With 4 NH3s, what do you guys think you're going to make? You're going to form Cu H2O Cu H2O 2 NH3 4 plus 3 NH, no, plus that plus 2H2O plus 2 OH minus ion. Now you can see why this is a disgusting one, because it doesn't fit the natural trend or the natural patterns. Okay, so you've got FeH2O6 2 plus 2 NH2 FeH2O4 OH2 plus 2 NH4 plus, green to green, CuH2O6 2 plus FeH2O6 3 plus 2 NH2 FeH2O3 OH3 plus 2 NH4 plus, orange to brown, AlH2O6 3 plus 3 NH3 to form AlH2O3 OH2 plus 3 NH4 plus, colors to white. And then copper, it's blue to blue precipitate and blue precipitate, blue solution, deep blue solution. CuH2O6 2 plus 2 NH3 to form CuH2O4 OH NH3 4. Yeah, I don't know. No, CuH2O4 OH2, yes. 2 NH4 plus, then you get this plus 4 NH3, and then you get CuH2O2 NH3 4 2 plus 2 H2O plus 2 OH minus ions. Okay. Now forget about me getting up and doing that. I'm not doing that, but let's just move on to the second one. So the third type we need to know, which is obviously with the carbonate ions. And after the carbonate ions, we've only got acid-base character, which is actually pretty easy. And then substitution with bigger ligands, which is one of the easiest ones. So it's really just acid-base character. So let's get through this now. So FeH2O6 2 plus. In this case, we're adding carbonate ion. So we're going to add CO3 2 minus, and then we're going to form FeCO3 plus 6H2O. Same thing with copper. But there's a special thing now you need to know is with the 3 plus ions, so with the FeH2O6 3 plus plus CO3 2 minus. What you're going to form is 2 Fe H2O 3 OH 3 plus 3 H2O plus 3 CO2. So check. OH3, yep, 0 to 3 is 2, perfect, and you also need a 2 here. And then same for aluminium, and that's really nice because then you're just reinforcing it by writing it down again. Plus CO3 2 minus to form 2 Al H2O3 OH3 plus 3 H2O plus 3 CO2. Okay, now let's go through the observations. So this was going to be obviously green to green. This one's obviously going to be blue to blue. The only one that's weird, oh yeah, sorry, no, this is green, this is blue to blue dash green, and then the rest of them are the same. So this is blue to blue dash green, and the rest are the same. The Fe is orange to brown, and this one's colourless to white, as you'd expect. Okay, and then finally, I'm thinking instead of doing this, we should maybe go through the substitution with bigger ligands. Yeah, let's go through substitution with bigger ligands. And then the acid-base character I'll do in a separate video because that is slightly more complicated. So, substitution with big ligands. So, FeH2O6 2 plus. And this is what I mean, like, you can really help yourself with these equations by writing which one is the exception to the rule and memorizing that, so you know, okay, so all of them are going to have the same equation except for aluminium with hydroxide ions, except for copper with NH3. Yeah, exactly. And then the rest of them, none of them react with excess carbonate ions. And this one, which I'm going to go through right now, there's no actual equation you need to memorize. It's just one for each one, which is beautiful. So you've got this plus your 4Cl minus your chloride ligands, FeCl4 2 minus plus 6H2O. Then you've got FeH2O6 3 plus plus 4Cl minus. So what's going to happen here? Well, I'm still going to form the same products, but this 2 minus charge is going to become a minus charge because I've got an extra charge, so obviously. And then I've got AlH2O6. Aluminium is obviously 3 plus 4Cl minus to form AlCl4 minus plus 6H2O. And what is the final one? Final one is copper. CuCl. Oh, copper is obviously 2 plus would flip. Yep. And the colours are exactly the same. All you need to remember is what they normally are, just to a yellow solution. That's all you have to memorize for the observation. Because you obviously know this one's going to be green to yellow, this one's going to be green. No, this one's going to be orange to yellow, this one's going to be colourless to yellow, and this one's going to be blue to yellow. Perfect. So FeH2O6 2 plus 4Cl minus from FeCl4 2 minus plus 6H2O. CuH2O6 2 plus 4Cl minus from CuCl4 2 minus plus 6H2O. FeH2O6 3 plus 4Cl minus from FeCl4 minus plus 6H2O. And then AlH2O6 3 plus 4Cl minus from AlCl4 minus plus 6H2O.